It doesn't read words, it converts every word into coordinates, like GPS for meaning.
Not one number, hundreds of them, all random.
So king and queen end up almost right next to each other on the map. But when a model first sees the word king, it has no idea that's true, because king starts out drop at the totally random point, sometimes right next to banana, and only grows next to crown after reading billions of sentences.
The AI that matters, every day.
So in today's video we'll talk about embeddings, that it took me a long time to understand, but I will try my best. So let's start with the exact definition. Embeddings are a list of numbers that represent the meaning of words based on what other words they hang out with, allowing computers to do math with concepts. Because computers don't work with concepts, they work with coordinates. As I said in the example, king had a coordinate, but they start randomly. And to get to next to king and queen, there have to be billions of coordinates so they can put it together. Because at the beginning, it might just be next to bananas. So they turn concepts into coordinates, like a GPS. So computers do not understand words or images. They only understand numbers, like the 1010 thing that you probably know. So they do not understand images or words or any kind of text. They only understand numbers. So that's why there's embedding, that turns a concept like a word or an image into a list of numbers, so AI can measure how related these two ideas are. So embedding what enables is AI to see the connection between words. So then you get a great output. That's why they are able to see the connections between words and how they're related they are to each one. So embeddings turns concept into numbers. So to help you understand this, let's put the GPS map analogy. So think of embeddings like GPS coordinates on a map. So let's start. We have this computer. We give it a raw text. For example, we give it the raw text Paris, Eiffel Tower. Just that. Raw text to this computer. Then we go to the embedding phase, the embedding model. It converts Paris and Eiffel Tower into map coordinates, into numbers, into coordinates. So for example, Paris is 48.85, 2.35, and Eiffel Tower, for example, 48.85, 2.29. So as you can see, they are very similar, because as more similar they are, that means that they have a connection between them, like that the Eiffel Tower is in Paris, and it's a great, like the most important monument in Paris. So because the numbers are almost identical, the computer mathematically calculates that the two concepts are practically sitting next to each other, that they share some kind of relation. So as we said in here, that they are a lot related, so they have almost identical numbers. So we had two ways of doing that. There was the traditional way, and then when it came embedding search. So the first way, it was traditional keyword search. You had, for example, let's put an example to help you understand it better. We have how to fix a flat tire. So the traditional keyword says look for documents containing those exact words, like fix, flat tire. So it looked through documents, it searched, as it says in here, through documents that contain these three words, fix, flat tires. Then the result was that it misses helpful articles if they didn't use those exact words, because there might be also documents that tell you how to fix a flat tire, but they might not contain fix, flat, and tire in the title of that document, so it missed those. So then when embedding search came up, for the exact same example, how to fix a flat tire, embedding search made that it convert your search into a coordinate location, into the GPS map, near a concept like, so it coordinated those fixed flat tires into coordinates into numbers, and then it located near concept the relation within others that have exact or similar coordinates, like for example car repair, punctures, and changing a wheel. So these ones share a similar location, a similar numbers, similar coordinate to fix a flat tire. So with this, your result, it finds, for example, automobile puncture guide, because each numerical location is right next to your curious location. So it's able to not miss those helpful articles that did not contain those exact words. Instead, it contains similar words, and now you have many more documents that help you how to fix a flat tire. So this is the traditional way, and this embedding search that it's used right now. So how it actually works? It goes through 5 different phases. The first one is text tokenization. Computers don't understand letters or words like large language models. So every word in a vocabulary is assigned to an ID number, to a token, like you may have heard of it, like large language models use tokens. It's their unit. We work with language, so they work with tokens. It's just a different unit for them. So they turn text into tokens, the text you write into tokens. Then we have this high dimensional initialization. So every token gets assigned a list of hundreds of thousands of numbers. A vector is called, these thousands of numbers, placing it at a randomly coordinate in an abstract space. So basically this phase 2 converts tokens into coordinates, into randomly coordinates. Then we have the training via concurrency. So the AI reads billions of sentences and learns words based on the distributional hypothesis, it's called. So this AI reads billions of sentences and learns these words, so it's able to convert these random numbers into more similar coordinates, that as we saw King and Queen or Paris and Eiffel Tower. Then we have this latent dimension alignment. So as the network learns from millions of examples in the previous phase, its internal coordinates naturally organize into meaningful concepts. So they organize into concepts. So we have a concept about cars, concept about food, even subconcepts about fruits, protein. So we have all these enormous concepts, so they are better organized. So basically in this phase they organize it into concepts. So we have the last phase, that it's vector arithmetic and nearest neighbor search. So because relationships are represented as physical distances and directions with the coordinates, so we have coordinates that are like physical distances or directions, you can do additional and subtraction with words. So this phase enables AI to learn the relationship, the correlation between those words. So if Paris and Eiffel Tower are really related or not, even though there are different concepts, because Paris it's a capital and the Eiffel Tower it's a monument, a thing that was built in there. So we have these different concepts, and then in this last phase it's able to put these relationships together and be able to know that the Eiffel Tower is related to Paris because it's in Paris, it's a monument, people go there to visit, and this kind of stuff. So it's able to relation all these concepts that we have organized in the previous phase. So we have how it actually works, and now let's look at a real example. The king, man, plus woman equals queen. This is a very common example that you might have heard of it, or if you search embedding search, you will find this example a lot. So for example, let's put you into context. We have man, that it has royalty 0, Gender 0. Woman has royalty 0, gender 1. King has royalty 10, gender 0, and queen has royalty 10, gender 1. So what it does following these exact phases, so the first phase, it subtracts man from king. So king minus man, it equals 10,0 minus 0,0, it's 10,0. So man has also 10,0. Then it adds woman to woman. So now we have 10.1, that this is the queen thing. And then it searches through the nearest network search, the thing that we talked about before, that instead of traditional, we have this embedding search. So now it's able to relation and recognize these three different things and how they are all relation. So the math results into the coordinate 10,1. So this AI scans its dictionary for whichever real-world vector sits at or near 10,1 coordinate, and the closest match in the entire embedding space is queen. So from king and man plus woman we get queen, and that's how these embeddings work. This is the core philosophy of embedding if you have understand this example. So I hope you learned something new today, and now from this theoretical part that everyone is using AI and these AI models, and this is the practical part, but you also need to know these concepts and this theory part so it helps you understand better AI and all the concepts inside it and how to prompt it better and get better results. And I hope you learned something new, and if you did, please give a like and subscribe because it helps me a ton. And I will see you on the next video. So thanks a lot.
That's how I build. One person and every AI in public. The AI that matters every day.